Hey there, and welcome to my video where I showcase the creation of procedural aquarium game art tools using Houdini for Unreal Engine 5. My objective was to explore the Houdini game development pipeline for Unreal and design free Houdini digital assets that are artist-friendly and allow for artistic direction. One crucial aspect of the project was figuring out how to simulate fish movement within the water volume. Initially, I considered creating a dynamic Niagara system with real-time collision queries, but ultimately I opted for a baked swim path approach. That is why I wanted to assess the performance impact of said features, particularly when rendering transparent materials like glass and water in close proximity. Before I start, I wanted to thank Sebastian Brenner for preparing some of the 3D assets shown in this video. I will provide a link to his portfolio and other resources used in the project in the video description. I also used various assets from the Megascans library for the mainframe aquarium tool. I created a basic scene in Unreal and I'm going to drag and drop the first tool into the viewport. The idea behind this vitrine tool is an aquarium or terrarium that is embedded into a wall. After the Houdini engine baked the output, I have a couple of parameters to play with. Let's start with the vitrine basic settings and change the aquarium dimensions. I can make it 1 meter wider and extend its height to 4 meters. I can also extend the walls from left to right individually to give the aquarium its mighty look. Changing the floor height and bumpiness is also very easy and can create a more interesting biome. Customizing the water level is also possible. Changing the water level parameter to 0 will fill up the aquarium completely. If I want to convert the aquarium into a terrarium, I can disable the water volume entirely. This will also get rid of the caustics effect and logically the fish swimming in the container. The next parameters I want to show you guys are the biome and fauna settings. I have the option to either disable the fauna completely or assign various types of plants individually. For this example, I will set the number of algae to 300 to show you how the fauna scatters around the floor. Also, let's modify the numbers of corals to 2 and observe the result. The underwater plant library includes hard and soft coral meshes, which occupy space on the aquarium floor surface. The vitrine tool has been designed to prevent overlaps between coral meshes and other plants. They require special consideration when constructing the biome within the container. Hence, they have their own dedicated segment in the parameter section. Furthermore, I can adjust the number of rocks in the vitrine by accessing the rock settings, or choose to disable them altogether if desired. It is important to note that the tool confines the rock shapes within the X and Y axis of the container. However, it is also possible to create a rock mesh that extends beyond the vitrine's hatch, should that be the output I'm looking for. Nice. When creating this project, I thought about how to animate the movement of the fish. The most obvious approach is to create a Niagara particle system for different types of animals, allowing them to swim within the water volume and potentially collide with the vitrine walls. My solution, however, was to calculate the swim paths in Houdini based on the dimensions of the water volume. The system should also consider coral meshes that could block the fish and store the result as a separate point cache file. First, I generate a number of closed curves in Houdini within the vitrine water volume that represent the number of fish I want to have in my example. For the actual animation, I spawn a point on each curve and animate it along the path with a carve node and bake the resulting data in a Houdini point cache file. To update my fish Niagara system, I need to replace the existing Houdini point cache asset with the new one. When swapping the point cache assets in Unreal, it is crucial to name the new file exactly the same as the already existing one in the content folder. The pre-configured Houdini to Niagara particle system then utilizes the updated file to refresh the swim paths for the fish. While this approach requires the extra Houdini to Niagara plugin, it offers the advantage of avoiding real-time collision queries for the fish during gameplay, resulting in an improved performance efficiency. One drawback, however, is the limited control over swimming speed and direction, as well as the need to bake the paths whenever I introduce changes to the aquarium dimensions or water level. Despite these limitations, I'm happy with the solution for now. The next Houdini digital asset I want to show you is the tube aquarium. During my research on various aquarium designs, I came across these captivating cylindrical enclosures, which inspired me to develop an extra tool specifically for them. It offers distinct parameter sections for the container, biome, and the aquatic inhabitants, swimming ironically in the water tank. So let's set the tube's radius and height to 4 meters and watch as the biome scatters across the expanded floor space. I can also disable the light stripe if I prefer a plainer design of the tube. In Unreal Engine 5, this emissive light contributes to the global illumination if I have lumen enabled. Moving on to the biggest aquarium of the project, the mainframe. My intention was to create a habitat suitable for accommodating larger marine creatures like sharks. The default dimensions of the mainframe are set at 10 meters in height and 20 meters in width. However, similar to the other tools, it is possible to adjust these measurements according to my preferences in the parameters section. To enhance the aesthetics and mimic natural underwater environments, I incorporated external cliff models sourced from the Megascans library. These formations are referenced to create cliff-like walls that align with the parameter of the mainframe aquarium. This additional stone geometry helps to make the aquarium look more believable. You may have noticed that the mainframe is the only tool in which I implemented the spawning of sharks within the aquarium. In this example, I downloaded an external shark model and edited it in Blender. You can find the link to the model in the video description. I employed a similar method as before to generate the swimming paths for the sharks in the mainframe aquarium, although this time Houdini considers the boundary of the cliff assets. Finally, I would like to introduce you to a more experimental water tank that I designed to test various performance features. One interesting aspect is the ability to modify the glass panel's material by selecting different options in the glass panel material settings. By choosing the Performance Single Layer option, a panel with a single layer water material instance is generated. According to the Unreal Engine documentation, the single layer water shading model is a cost-effective method that offers translucency using a single depth layer. That's why this shading model is an adequate candidate for my use case. This shader also allows me to adjust the level of murkiness in the material settings, enabling me to achieve diverse styles and levels of water depth. Besides the single layer option, there are other choices available for the appearance of the aquarium glass, including a standard Unreal translucent material or an additive unlit glass material that optimizes rendering efficiency. For this showcase, let's opt for the latest and greatest shader model Unreal has to offer, the thin translucent material. With this shader I can accurately depict tinted and colored transparent glass, however it's the most resource intensive material to render. When switching to the shader complexity view in Unreal, you can see how expensive it is to render this material in conjunction with the water volume. Unless you're packing some serious GPU in your gaming rig, this option probably exceeds the memory budget of the target platform like VR or mobile games. Generally, in game development, rendering two transparent materials in tandem can be very expensive. That's why one has to be careful creating a glass aquarium container that is partly filled with water. Let's deactivate the tank filled option and observe how performance took a significant hit. In this specific scenario, the tool needs to generate geometry for both the glass walls and the water volume, which entails rendering two consecutive non-opaque materials. Therefore, it's best practice to create a single volume that acts as the glass facade and the water volume at the same time. Certainly, there are various features and quality of life improvements that can be addressed to enhance the user-friendliness of this generator tool. Although this project was my first step into the Houdini game development ecosystem, I'm planning to venture into other tech art topics related to Unreal Engine. That's it for this video. Thank you for watching, and if you have got any questions about this project, feel free to leave a comment below.